It's great to be back in part of the Nextflow community. It's been 5 years since I've actually given a talk in person. Last year, somehow I did a virtual talk in Barcelona. They worked out okay, thanks to, thanks to the team. The time difference really screwed me up, so this is much better. Today I'll talk a little bit about harnessing genomics in Microsoft Azure. And really, what we've seen, the system is really ripe for innovation. And as we've seen in the last year, artificial intelligence represents a lot of what we've been doing and pushing, but it's not the only thing we're pushing. And there's a lot of innovation that can happen in life sciences and what we're doing here with workflows and pharmaceutical companies. So I'm part of a health life science research group. So our mission is to empower every person to kind of live a healthier life, and we're trying to empower research, right? And so what we really want to do is kind of have research discovery, do the testing, monitor, diagnose, treat, come back to discovering, developing new tests, and keep going back and forth, right? And this feeds into not only the development of new diagnoses and treatments, but also on how we do development. One of the biggest things we've been doing in the last couple of years is how do we improve development and testing of genomics workflows and kind of democratize the use of the tools that have been developed by the community. Last year, we really worked closely with the community and GitHub and Nextflow. We needed to quickly develop, test, and commit changes in a virtual environment. And so we have GitHub code spaces that we developed that gives us a purely isolated development environment in the cloud. It's customizable for every project. Can run on a different set of VMs, 2 to 32 cores. And it's all in browser, but it can also be run on your VS Code desktop. And what we've done here is actually installed Nextflow, NF Core tools, VS Code linting, as well as Docker. And this provides you with effectively an isolated environment to do all your testing of stubs, development, and pair programming. I used this extensively in the mentor-mentee program last year. My mentee was actually in Australia, and I was in the US, and at midnight we would do pair programming using VS Code, and we were able to quickly test. And we actually used the code spaces as our head node, right? So he was able to launch it from there, and we were both able to actually see all the error messages and quickly debug, which was a great way for us to program. This is one way of helping with the testing and development, but one of the things we've been developing over the last couple of weeks and months is the era of copilots, right? This is AI pair programming, right? So the next evolution of the in-person pair programming. And right now, GitHub Copilot is trained on all the languages that appear in the public repositories. This has some drawbacks, right? It's dependent upon what's available in GitHub and public and the good source of truth for those. Some languages are better than others based on how representative they are in GitHub. And we're seeing a lot more papers and white papers coming out on personalization, customization of these tools. And we are also adding this to GitHub Copilot Enterprise in the next year. But does this mean we actually have a Nextflow Copilot? Kind of. As you can see, if you ask Copilot, you could say, I want a Minimap 2 alignment. It kind of gives you a stub of a Nextflow process. It's not great. It's not perfect. It's a hybrid between DSL1 and DSL2. It doesn't give you Docker images. It doesn't tell you all the options that you want. But if you didn't know where to start, it's as good as a template. But is the response actually useful? Maybe not. So if we actually give this again, we generated Azure OpenAI, and then we trained it on the NF Core modules as examples, which we think is a real good truth data set of how to write good Nextflow pipelines and modules. And what we're able to do is vastly improve what this got us. We're able to get a full process with all the information from NF core. If the process already existed, it didn't recreate it. It just pointed you to which module to actually just add to your pipeline. What this also did is if you try to tag together a couple different processes, we actually, it's hard to see, but we reference exactly which metadata that YAML, the .nf files that were used as references to build this, right? So then you can always go back and see what is going on and maybe add those. Right, so there's a bunch of differences. Our syntax is a lot better aligned with NF core. We have the more of the options in a well NF core and Nextflow DSL2 structure. And overall, I would say it's maybe 90% better than what we had previously. But this is where we need the Nextflow community's thoughts. What is important for when we look at Nextflow code, right? Are we looking at syntax? Are we looking at script selection, sections, container sections, tool documentation? Are we getting a summary of what's in the process? Do we need tests and generating those unit tests? That's the next level, right? That's where going to the community and coming back and iterating of what this next model would look like. So our plans are to go with the community, elicit responses on Slack and see if we can test how useful it is. And where do you draw the line, right? Where does it become useful and where does it become a hindrance on actually developing pipelines? What we're trying to do right now is to identify how do we measure that quality. The next thing we're also looking at is how do we get better at understanding the bioinformatics tasks and tools and options are available there. Right now, not all the tasks have all the tool options in it, and that's part of the gap in training. Can we train it on all the bioinformatics tools available? So I'll be around today and tomorrow, so if you're passionate about Copilot and testing LLMs, please just grab me and we'll talk and we can set up a Slack channel on Nextflow and keep going from there. Additionally, we've been helping with the NF core community support, providing additional credits so we can test all the NF core pipelines in Azure. We've been working on the Azure mega test with Sarek, so hopefully once Sarek passes, I think all the rest of the 99 repositories should easily pass. So fingers crossed, we'll get there. But one of the biggest other hurdles that we've been seeing is how do you deploy your pipelines in the cloud? Nextflow makes it pretty easy with configs, but there's a lot of data tools, community-driven activism, stakeholder sponsorship. There's a lot of problems with this. So we don't want to proliferate another standard, but we are proliferating another standard. But we're working with the community, with the GA4GH community, to develop the Task Execution Service API. The idea here is that it's a lightweight deployment model, right? It can run on AKS or even just a container instance as a Docker container. It's a simple API. Right now, there's already a plugin for Nextflow, so you don't have to do too much development. The idea that is we would help develop the backend for Azure. There's already a test API also for Slurm clusters, and there's one that's developed in Europe for Kubernetes. So the idea is that we would not have to hit multiple endpoints. You would just hit the same test API, and then you could do compute on any different endpoint. We have deployment instructions for Azure, which is all open source. We deploy a Azure Postgres database. We can run it anywhere. And then we do the distributed compute currently on Azure Batch, but there's nothing stopping us going from a different compute environment in the backend. And then we have additional security that we've done to harden the network infrastructure and security requirements. So effectively, we have this basic architecture where you can deploy this test endpoint in a Kubernetes cluster, and it handles all the responses to Azure Batch, but also Nextflow just talks to the test endpoint. and it provides you with the low cost effective, what's the lowest cost, cheapest machine needed to run your compute, and does all the scaling. So our next steps is to improve documentation and handling, being compliant with PHI level, and we are currently testing and working with engineers within Sakara to fully do full Nextflow support. Right now it's partial support, there's some gaps, but we're hoping in the next couple of months we'll be able to bridge those gaps. Thank you.
Thank you so much. Always delighted to see GA4GH standards getting featured. All right, a question for you. Can Copilot diagnose or help with cryptic errors during a Nextflow run?
Maybe. This is where we would actually want to work with Sakara to see if we, and the community, see if we can improve that, right? Right now it's only trained on code. If we can train it on Slack messages or other options, we can probably get better responses on what those error messages are.
Kind of related as an example of something that people would want to see, can Copilot tell me what to expect the contents of a channel will contain? Because that would be very helpful.
I don't know. We can test it and see if it does. It's a good idea.
That's a good answer.
Yeah.
Thank you. All right.